This file robotcommand.cs defines a class named robotcommand that represents a robot command stored in the system. Now let's see at its properties and the constructor. In its properties, first we have the ID. It is an integer representing the unique identifier of the robot command in the database and it has a getSet property. Next is the name. Next, we come to the description. Description is an optional string containing the actual working of a robot command. It is also getSet property and it is not required. It can be put or cannot be put. Next is the isMove command. It is a boolean that indicates whether the robot command is a movement command for the robot or not. Next is the created date and modified date. These are the objects representing the date and time of the robot command was created and modified. Next we have the constructor. This class provides a constructor that takes 6 arguments that are id, name, isMove command, created date and modified date, and description. It initializes the properties of the robot command object. Now let's move to the robot command data access file. This file defines a static class named robot command data access that provides methods for interacting with the robot command table in PostgreSQL database. First, we have the connection string. Next, we have the get robot commands. This first method is used to retrieve all robot commands from the database and returns them as a list of robot command objects. Next, we have get move commands only. This method retrieves only robot commands that are marked as move commands uh, from the database and returns them as a list of robot commands object. Next, we have get command by ID. This method takes an integer command ID and retrieves the corresponding robot command from the database by its ID. It returns a robot command object or null if no command is found with the given ID. Next we have get command by name. This method takes a string command name and retrieves the robot command from the database that has the matching name. It returns a robot command object or null if no command is found with the given name. Next we have add robot command. This method takes a new robot command object as input and attempts to add it to the robot command table in the database. It returns true if the command is successfully added, otherwise it will return false. This method uses parameterized queries to prevent SQL injection vulnerabilities. Next we have the update robot command. This method updates an existing robot command in the database. It takes the ID of the robot command to update and a robot command object containing the updated information. It returns true if the command is updated successfully, otherwise it returns false. Similar to add robot command, it uses parameterized query for security purposes. At last, we have the delete robot command. This method deletes a robot command from the database by using its ID. It doesn't rely on any value but directly executes the deletion command. Next, we have the robotcontroller.cs file. This file handles the HTTP requests related to robot commands in my ASP.NET Core Web API. First, we define the class. The API controller indicates that this class is a web API controller. Next, we have the route defined. This attribute specifies that the base URL route for all actions defined within the controller. Next, we have our methods. The first method is get all robot commands. It is a get request. It retrieves all robot commands from the database using the get robot commands method. It returns an IEnumerable robot command containing all robot commands as a list. It produces response types of 200 if okay if commands are retrieved successfully, and 404 not found if no commands are found in the database. Next we have get move commands only. It is also get request. It retrieves only move commands. Commands with the property is move command set to true. It filters retrieved commands from get or robot commands using where clause. It returns an IEnumerable robot command containing only move commands. It also produces response time to document the expected 200 OK status code. Next, we have get robot command by ID. It retrieves the robot command by the given ID. It also has response codes of 200 and 404 not found. Next, we have add robot command. It is a post request. It creates a new robot command. It uh, it takes robot command object representing the new command details from the HTTP body and returns an IAction result. If new command object is null, it returns an error 400 bad request. Otherwise, it adds the command using robot command data access.add robot command new command. If successful, 201 created. It returns a created at route result that includes the newly created command's ID and link to retrieve it. Next, we have the update robot command. It is a put request. It updates an existing robot command with the specific ID. It takes the robot command object containing the updated details and returns IAction result, in which a 404 error is given of not found result. Otherwise, it updates the command property using provided details and calls robot command data access.update command to process the changes. If the update is successful, it returns 200 OK with a successful message. At last, we have delete robot command. Delete request. It is a delete request using the ID given by the user. It returns IAction result. If the command with the given ID is not found, a 404 error is returned. Otherwise, it deletes the command using robot command data access.delete robot command by ID. If deletion is successful, a success message of code 200 OK is returned. Similar to robot commands, we have map commands. It has the following properties: ID, columns, row, name, description that is nullable, date time of created date and modified date, and its constructor. Similarly, we have map data access as explained earlier in robot command data access. It also has a connection string and it is used to connect to the database of the PostgreSQL. First, we have the get all maps command. In this, we are sending a get request and fetching all the data of all the maps that have been previously created in the table. Next, we have get square maps. In this, we only retrieve the maps that have the rows and columns of same number. Next, we have the get map by ID. Similar to robot commands, here we input a ID as being a user, and if the particular ID is available in the database, we get the particular map that is associated with its ID. Next, similar to ID, we have get by map by name. Here we give a name of the map to retrieve the map. Next, we have add new map. In this, a new map is added with the user given data of the required rows and columns name, description, and a new map is posted. In this, it returns a bool value whether the map is created or not. Next, we can update a map and change the number of rows and columns it has. It is a put command and it also returns a bool value. Next, we have the query of the delete map. In this, we can delete a required map by giving the map ID, and it will delete the required map if it is available in the database. Next, we have the command for check coordinates. In this, what we do is we input a ID and x and y coordinates. It goes to the database and checks the particular map. If the particular map is available, it then checks the number of rows and columns available in the map. If the rows and columns match, or is if the rows and columns in the map are present as we put by the user, like if we put x as 2 and y as 3 and the map has the x and y coordinates as 4 and 5 respectively, it means the user required 2 and 3 are already available in the map, so it will return true. Otherwise it will say false, that the coordinates requested by the user are not on the map. Similar to mapped robot controller, we also have a map controller. In the map controller, we are using the endpoints that we created in the map data access file. Here we can add a map using post request. We can update a map using its ID using put request, or we can delete a map using its ID, or we can get a map using its ID and the coordinates, the last endpoint I've showed you earlier. So this is all about map controller files. The main purpose of this task is that before what we did was that we added the data during the runtime, and when we close the program, like when we press Ctrl C and the uh, program closed, the data was not saved anywhere. It just simply vanished away. In this task, what we did was we connected it to a backend table like form. We have used npg In that, we can actually save the data and it will remain there even after we close the program. So that was the basic purpose of this task. Now let's see the output. Okay, so it has been started. Main we have used is this. Using this, we are able to connect to the backend server that is present, the table, the database. This is the main string that is used to connect to it. Without the string, we won't be able to do anything. Now let's see the commands. First is the get command, which is gives us all the commands that are present in the database. Then we can get move commands that have the isMove property set to true. Here you can see in all the commands the isMove property is set to true. Then we can read the commands using the ID. Okay, so we can post a new command, we can delete a command, we can update the parameters of a command, its name and isMove command. And similarly, we can access the maps. Like we can get all the maps that are present with ID 2, 4, 5, 7. These are the IDs of the map and the description they have, and these are the names of the map. Similarly, like robot commands, we can get square maps. Like were able to get move commands. Similarly, we can get square maps. In this, we will get all the maps that have same number of rows and columns. See, same number of rows and columns here, here, 6, 6, 7, 7. These are same. So these are known as square maps. Next, we can read the maps using the ID. ID of the map, we can read the map. ID number 4 map with 3 columns, 5 rows, name is new map, no description is available. We can update a map similar to the previous one and post a new map, delete a map, and this last command is to get map coordinates. Like in map number 2, the 2, 2 coordinate is available or not. As we can see that it is available. So this is from the Postman side. Now let's visualize the database using the actual tables. Now let's find our actual tables. Here are our tables. This is the map table, first of all. See, these are all the maps that we were able to see in the Postman. This is its a square property, and the number of rows and the columns in the map, the name of the map with its ID. Similar to maps, we have also robot commands. This is the table of the robot commands. The name of the robot command, the IDs of the command, is move command is true or false, the created date and the modified date. This is the actual visualization. The actual data that we run the endpoint there, it gets saved in here. So this is all about the task persistence layer. Thank you.